Here is a third example of using Pythagoras Theorem. In this question, I put some stars beside it. It's what I call a backwards question. And you'll see why I call it a backwards question shortly. Our job is to calculate x correct to two decimal places. So you got 8, 3 and x on a right angle triangle. Now, the first step in Pythagoras Theorem questions is to label your three sides h, o and a. Now, the most important side is getting your hypotenuse. Here is our right angle, so across from that is your hypotenuse. Now, you'll notice that in the previous questions, x happened to always be the hypotenuse. In this question, x is not the hypotenuse. The hypotenuse here is 8. So this is why I call it a backwards question, because the thing we're looking for, which is x, is not h. Now, I call my other sides O and A. It doesn't matter which one is O and which one's A. So I'm going to call this one O and this one A. Now, Pythagoras' theorem says that h squared is always equal to O squared plus A squared if it's a right-angled triangle. So let's sub in here and see what happens. Our h number is 8. So it's going to be 8 to be squared equals... My O number is x, so it's going to be x squared plus, and my A number is 3, so it's going to be 3 squared. And you'll notice in this example, the x squared is here in the middle. It's not on the left on its own. Well, we continue as normal. Use your calculator to find 8 squared. 8 squared is 64. X squared stays as x squared, and 3 squared is a 9. Now, what we have to do in this particular example is we need to get x squared on its own, either on its own on the right or on its own on the left. What I'm going to do is I'm going to leave the x squared on the right hand side of the equals, and I'm going to get rid of this add 9. And to get rid of an add 9, we bring it over to the other side and do the opposite. So the opposite of adding 9 is taking away 9. So we're going to have 64 take away 9. And if I just do it on a calculator there, 64 take away 9 is 55. So we have 55 equals x squared. And at this stage, I can rewrite it as x squared equals 55. Why can I do that? Because if 55 equals x squared, then x squared equals 55. But I don't want x squared, I want x. So how do we get x on its own? We get the square root of 55. And then we can use our calculator to figure out what the square root of 55 is. So I'm going to go square root 55 equals, and notice square root of 55 comes up my calculator screen. I want it in decimals, so I press my SD button. And up comes 7.41619. Now, how many decimals do they want? They want 2 decimal places. So this is going to be 7.42. 7.42. So the answer is that x in this question will be 7.42. And I can always update my picture if I want and put in the new information. And it should make sense because the hypotenuse should be the longest side. And 7.42 is shorter than 8, so I'm happy with that. So that's example 3. Now, one last example of Pythagoras' theorem here is we have another question here, example 4, and it says calculate y. Write your answer in surd form. Now, this is important. If you see surd form means they don't want decimals, they want square roots. If there's a square root in your answer, you leave it as a square root. Okay, so let's see what happens here with this one. Okay, so the first step is we see it's a right-angled triangle. So we know if it's a right-angled triangle, we know Pythagoras' theorem should work, or will work. H squared equals O squared plus A squared. To use it, we need to label them O, A, and H. Which one is going to be h? Is it the 4, the 2 or the y? Well, look, here's our right angle. So across from that is h. So in this one, y is h. And then O and A, it doesn't really matter. I'm going to call this one O and this one A. But if you put them the other way around, that's fine. The sum will still work out. We then sub in. So instead of h squared, we're going to have y squared. Instead of O squared, we're going to have 4 squared. I like to put them in brackets. Instead of a squared, we're going to have a 2 squared. Okay, so next step, y squared equals 4 squared is 16 and 2 squared is 4. And then we work that out by adding 16 and 4 and we get 20. Now, last step is we don't want y squared, we want y. So y is going to be the square root of 20, because the opposite of squaring in maths is square rooting. And if I type in square root 20 into my calculator and press equals, an answer comes up as 2 root 5. And we don't press the SD button like that because they didn't want decimals this time, they wanted in third form. So 2 root 5 is my answer. So there is the answer. Notice third form just means you leave it looking a bit weird like this with the square root. We could leave our answer as square root 20. However, your calculator does break it down to a more simple third, 2 root 5. So that's the answer we're looking for.